So this is the topic of torque on a dipole placed in electric field, uniform electric field. Okay, torque on a dipole placed in uniform electric field. So we know this is the formula of electric field. This is general formula of electric field. It is force per unit test charge. E is equal to F by Q. So F can be written as QE. So this is the formula that we will make use of. Coming to the diagram I am drawing once again to explain. So you can see this is uniform electric field. These arrows are representing uniform electric field, and this is the dipole. This is minus Q and this is plus Q. Okay, and length of the dipole is 2a. And this is theta, this is theta, this is theta. So dipole is making an angle theta with the uniform electric field. Okay, theta is the angle between dipole and dipole moment and electric field. Fine, they are inclined at angle theta. Now coming to force, I said we will make a use of this formula. We will make use of force formula. So force on minus Q charge is Q into E, charge without sign. Okay. So it is along negative x-axis. Why I have written so? You see here, electric field is always from positive to negative. So this is your positive, this is your negative. This is small positive and this is negative. Because electric field is always from positive to negative. So this negative Q will be attracted towards positive. So that is why I am writing this is along negative x-axis. Force on minus Q is along negative x-axis. But plus Q, look at plus Q. This is plus Q. This is plus Q. This will be along negative. This is negative. If it is not clear, see again. Electric field is always directed from positive to negative. So this positive charge, this plus Q is feeling a force. This plus Q is feeling a force towards this negative. So this is along positive x-axis. So I have written here force on positive Q is again QE, general formula, and it is along positive x-axis. So both the forces are equal and opposite. Force on plus Q is equal and opposite to force on minus Q. So both the forces are equal and opposite. Net force is 0. So there is no linear motion in this topic. But these forces are acting along different lines of action. So they are producing a couple and will produce torque. So torque formula is given by either force into perpendicular distance. Force is QE. You can see both the forces are QE only because sign is not taken, and perpendicular distance. This distance you know, this is length of the dipole, which is 2a. This angle you have seen in the diagram is theta. So perpendicular distance is 2a sin theta. So 2a sin theta substituted. Now Q into 2a is your P. So final formula of torque is P sin theta. Torque on a dipole. It's not torque on a coil. Coil kept in magnetic field is Niba sin theta. This is torque on a dipole kept in electric field, and that is in magnetic field. Okay. So this in vector form, this can be written as this. In vector form, this is this. Torque is always perpendicular to this. First dipole moment vector and then electric field vector. And direction is given by right hand thumb rule. Direction of torque can be found by right hand thumb rule. Clear? Right hand thumb rule.